Deadlocks in Java. So I will show you one demo about how deadlock is happening. Okay, it's a live demo in my IDE. So here you can see this application running. Okay, but it is still not stopped because it is in deadlock. How it is happening? Here you can see I have created lock A, lock B. Then here you can see I created two threads T1, T2. In T1, there is a synchronized block. I have lock A I am acquiring here. Inside synchronized block, first synchronized block, there is another synchronized block which is trying to acquire lock B. Okay, so this is one thread. There is two synchronized blocks is nested. So first it is trying to acquire lock A, then it is trying to acquire lock B. Okay, in thread 2, second thread, here same thing, but it is first trying to acquire lock B, then A. T1 first lock A, then B. Here T2 first lock B, then lock A. Okay, so while running, what is happening? Here you can see thread 1 acquired lock A. Here it is printed. Thread 1 acquired lock A means this is thread 1. It acquired lock A means it entered into the first synchronized block and it printed this. Then it should print thread 1 acquired lock B, but it is not printing because it cannot enter inside here because of deadlock. Because meantime thread 2, what happened? It acquired lock B already. Okay, so in the beginning you can see both T1 and T2 starting together. So in the first execution, T1 and T2, what it will do? First T1 will acquire lock A, T2 will acquire lock B. Next T1 is trying to get lock B, but T2 is already acquired lock B. Similarly, T2 is trying to acquire lock A, but it is already locked by T1. It's clear, right? So here is a deadlock. That's why the program is still running. You can see here it is still running. Ideally, it should complete in milliseconds, right? But still it is running. It is still waiting to acquire the lock, but it will never get. So how to detect this deadlock? Okay, this I am saying that there is a deadlock, but how you can confirm whether the deadlock is there or not? For that, there are multiple ways. I will show you. First, what we can do is we can use jstack. Okay, so jstack is a tool which helps to identify deadlocks. Okay, so in jstack, the how to do it? It means in jstack we need process ID. Okay, so I am giving like jps minus l. So jps minus l will list down all the process IDs here. Process IDs of Java only. Okay, here our application is deadlock demo 1. So here process ID of deadlock demo 1 is 29268. Okay, 29268. So now I am running jstack, then process ID 29268. Here I can see found one deadlock. It is explaining little bit here. Okay, you can see read all this. It's clearly mentioning what is happening. Thread 0 and thread 1. It acquired the first lock, then it is trying to acquire second. Found one level deadlock. Thread 0 waiting for lock and thread 1 is waiting for lock. Okay, whatever thread 0 is trying to acquire is held by thread 1. Whatever thread 1 is trying to acquire is held by thread 0. So it is a deadlock. Okay. So this is how you can see deadlock. You can confirm deadlock with the jstack. Okay, it is jstack will clearly explain thread 0 waiting for thread 1 is waiting for thread 0, so it will never end. It's clear, I believe. Okay, another way of detecting thread lock is we can use VisualVM. Okay, so I will go to my present working directory. So I have already installed VisualVM in my system. So inside bin folder I can run like this /VisualVM, and I am setting my JDK home. It's optional. If you are not setting means by it whatever the default Java version it will pick it, but I am setting it to 23 because VisualVM my default version is Java 25, but VisualVM not supporting Java 25, so I am explicitly mentioning run it with Java 23. So here you can see my VisualVM is open now. Inside VisualVM I can show you in the left side whatever application is running, it is by default it is showing like the JPS we listed down the processes, right? Similarly it is also listing down the processes here. So this is our application Deadlock demo 1. So I am double click Deadlock demo 1, so it will open another panel here. Here I can see the threads. I'm clicking on the threads. Here it is saying deadlock detected. Okay, so here it is giving more clear message. Okay, deadlock detected. If you want to take a thread dump, we can take it, we can analyze, we can show that information whatever is shown in the jstack, right? Similar kind of output you will get if you are taking a thread dump. More information will be there, you can go through it and you can identify which thread what exactly, but it will give you immediately a message like thread lock is detected in your particular application. This is VisualVM. Okay, here is a icon called thread dump. If you want you can take a thread dump. Okay, it will give you the complete log, the thread logs you will get here, so you can read and understand what is failing, where it is failing, etc. Thread 1, thread 0, the same thing whatever we shown in the jstack, it's similar kind of message you can see here. Thread 0 waiting for thread 1, thread 1 is waiting for thread 0, so it is a never ending. Okay, this is the VisualVM how to detect thread lock with VisualVM. So this is the demo about deadlock creation and deadlock how to identify deadlock. How to fix the deadlock I will cover after this explanation. Okay, after this presentation I will explain you how to avoid deadlocks. So what is a deadlock? Two or more threads is involved. In a deadlock, it's obvious two or more threads are involved. Multiple independent execution paths running concurrently within the same process. That you should already see, right? Multiple independent execution paths running concurrently within the same process. And holding resources. Each thread has acquired exclusive access to at least one resource and refuses to let go. Waiting forever. Each is blocked indefinitely, waiting for a resource currently held by the other. Here you can see this is thread 1, this is thread 2. Okay, this is waiting for this is waiting for this. So it is kind of a circular dependency cycle. Okay, so it will never end. That's why we are calling it deadlock. In a real world scenario, person A currently holding key 1, person B currently holding key 2, then person A waiting for key 2 and person B is waiting for key 1. So what will happen? The one key 1 is person B waiting key 1 but which is acquired by person A, and person A waiting for key 2 which is acquired by person B. So nobody can proceed. This system is frozen. This is a deadlock scenario. Coffman conditions. These all are the conditions very popular, and you may heard it multiple times or in interviews and all. There's a high chance to ask this question. What is Coffman conditions? Otherwise, what all are the when a deadlock occurs? That can be another question. Okay, when a deadlock occurs. So deadlock occurs only if all four conditions are met. Okay, we call it Coffman conditions. Okay, first condition is mutual exclusion. Resource can be held by only one thread at a time. Okay, second one, hold and wait. Thread holds a lock while waiting for another. Then no preemption. Locks cannot be forcibly taken, must be released voluntarily. Okay. Then circular wait. A closed chain of threads waiting on each other. So these all are the four conditions for deadlock. Deadlocks occurs only if all four conditions are met. So and 1 and 2 and 3 and 4. If all these conditions met, deadlock will occur. So first is mutual exclusion. We have discussed about four conditions, right? So we are going through one by one. So mutual exclusion, a resource can be held by only one thread at a time. So this is synchronized block, means only one thread at a time can access this block. Okay. So a resource can be held by only one thread at a time. Others must wait until released. So until this lock getting released, others must wait. They cannot force this to release, or they cannot acquire this without this particular thread releasing it. So it is this particular thread voluntarily release it, then only others can access. Okay. Then without mutual exclusion, race conditions occurs. With it, deadlocks become possible. Okay. So mutual exclusion is very clear. A resource can be held by only one thread at a time. So that is the first condition. Then second condition says hold and wait. A thread holds one lock while waiting to acquire another. Okay, lock A acquired. Okay, then it's held. Then it is waiting for lock B. Hold and wait means hold, lock A is on hold and lock B is on wait. Okay, in this scenario, this is the second conditions for a deadlock. Okay, so first condition is mutual exclusion. Second condition is hold and wait. Key pattern, nested synchronized blocks are the most common cause of this condition. Here you can see two synchronized blocks nested. Lock A, it already holding lock A. Then it is waiting for lock B. Okay, this is a second condition for a thread lock. Then third condition is no preemption. Resources cannot be seized, locks cannot be forcibly taken away from a thread by the OS or another thread. Voluntarily release only. A thread must finish its task and explicitly release the lock voluntarily. So Java synchronized locks are non-preemptive. Once a thread enters a synchronized block, nothing can stop it or take the lock away until it exits the block naturally or throws an exception. So no preemption. This is the condition 3. So this is clearly saying locks cannot be forcibly taken away from a thread by the OS or another thread. A thread must finish its task and explicitly release the lock voluntarily. This is the third condition for a deadlock. Then circular wait is the most important thing. Okay, thread 1 acquired lock A, wait for lock B. Thread 2 acquired lock B and wait for lock A. So it's a circular dependency. A depends on B, B depends on C, C depends on again A. So it will never end. It's a kind of circular wait. Okay, it's a very important. This is what happening in most deadlock scenarios. So simple deadlock diagram. This is already, you know, right? Thread 1, thread 2, thread 1 acquired lock A and waiting for lock B. Thread 2 acquired lock B, waiting for lock A. So this infinite loop, infinite waiting. So deadlock code example. Okay, two threads attempt to acquire the same locks in opposite order. Here you can see deadlock demo code. I already ran it in front of you. So this is the code. Once both threads enter their first synchronized block, neither can process it. The application hangs indefinitely. Okay, in this scenario, what happened? Both can enter the first synchronized block, then it going to deadlock. It going to wait infinite time. Okay, why it is happening? Because both the threads acquiring the lock in a opposite order. Okay, because thread 1 acquiring lock A in the first section, thread 2 acquiring lock B in the first block. That's why this is happening. The opposite order is the issue here. Okay, two threads attempt to acquire the same locks in opposite order. This unsafe order. Okay, this is the deadlock code example. What happens at runtime? Program starts, acquire first locks, T1 gets lock A, T2 gets lock B, wait for second lock. T1 waits for lock B, T2 waits for lock A. Okay, then infinite wait. Neither can processed, state is blocked, app frozen. It's very clear. In the above previous example, what happened? That is explaining here. Okay, in the previous example you can see thread 1, thread 2 and synchronizer blocks, right? So actually what's happening is explained here. First the program starts, threads T1 and T2 are spawned, acquire first locks, T1 gets lock A, T2 gets lock B, wait for second lock. T1 waits for lock B, T2 waits for lock A. So it's an infinite wait, neither can processed, state is blocked. So app will be frozen. System monitor, CPU usage is 0 because deadlock is not consuming anything. It is simply waiting. It is not consuming resources or memory or CPU. So it is low resource usage. Unlike an infinite loop, which spikes CPU, right? Infinite loop. But a deadlock causes threads to sleep, resulting in near zero CPU usage while the app is frozen. If the app is frozen means CPU usage is nearly zero. It don't do anything. It will simply frozen. Detecting deadlock with the jstack. This I already demonstrated. So you can have a quick look here. Whatever I did is already explained here. Okay, jps minus l, we got the process id, then jstack process id will give you the deadlock information, the deadlock information. This is a standard jdk utility. Jstack is a standard jdk utility. It's a command line tool included with jdk. You don't need to install it separately. It comes with jdk. It prints stack traces of all threads for a given process id. So verify consistency means a single snapshot might just catch a slow thread. Deadlocks persistent indefinitely. So you can do it 3 times in a 10-second gap. If the threads are stuck in the same place in all 3, is a deadlock, right? Yeah. Detecting with VisualVM. This is also I already showed you deadlock detection with the VisualVM. Next is how to fix the thread deadlocks. Establish a lock ordering is the first type of fixing. So here how I fixed, both threads follow same order. T1 first acquiring lock A, T2 also first acquiring lock A. Then AB is the same order, both the threads following. Okay, so what happens? This is a global order. If all threads acquire locks in the exact same sequence, a circular wait becomes impossible. How? Because thread T1 acquired lock A, at the same time thread T2 will try, but it will not get. But once it is released, it will get. Okay, then that time this will try to get a lock B. Then after lock A, it will try to get lock B. Meantime, this will complete, and this you can second thread can easily access. So this is the fix we call lock ordering. So if we are ordering it in a proper way, thread lock may not occur. Okay. The result of this code is thread 2 waits for A. Thread 2 waits for A instead of grabbing B first. Okay. So thread 2 waits for A instead of grabbing the B first. So both will continue the same order. So no deadlock here. Second one, use try lock. Okay. Try lock, you can see here. We have a condition. If lock A dot try lock, then if yes, if this is returning yes, then it will try to acquire lock B. If this is also giving yes, do something here. The finally is mandatory here. You have to unlock the lock. Okay, you have to unlock the lock after you consumed both lock. If you lock A, lock B you unlock, lock A you unlock. So this is a conditionally we are doing. We are checking. This is re-entrant lock. Okay, this is comes along with Java concurrent package. So this is very useful to avoid deadlocks, because conditionally we are checking and it is trying to acquire. So two if conditions. If first it is trying to lock A, then it is trying to lock B. Then after the processing, it will unblock B first, then it's unlock A. So this is very safe method. Okay, so always use finally block to ensure locks are released. Okay, that you understood, right? So if you release only, someone else can use it. So avoid the advantage of try lock. It avoid infinite waiting. Use re-entrant lock, try lock to attempt acquiring a lock without blocking forever. If failed, back off and retry. The main advantage is no infinite wait. Unlike synchronized, try lock returns false immediately if the lock is busy. Okay, so that is a main advantage. Unlike synchronized, try lock returns false immediately if the lock is busy. So timeout support can wait for a specified time. Try lock 100, time unit milliseconds. It will wait for 100 milliseconds. Then only it will return back. Okay, if it is not, if the lock is occupied, it will wait for 100 milliseconds and check once again. If it is found, it will acquire. Otherwise, it will say it will return false. Okay, so timeout support is there. This is second method to avoid deadlock. So third method, reduce lock scope. Okay, what it means is minimize hold time. Longer lock duration, higher probability of blocking other threads. Okay, so do minimum things inside synchronized block. If you can do something outside, do it outside. Whatever is mandatory to go inside synchronized block, you can add inside synchronized block. Don't put everything inside this synchronized block. Okay, that is the minimum hold time, so that it will take minimum time only. Then isolate critical sections. Only synchronize lines modifying shared state. Move logic outside. The same thing. Okay. Keep minimum things in synchronized block. All other operations keep outside of the synchronized block. Avoid alien methods. Never call overridable methods inside a lock. Unknown locks cause deadlocks. So these overridable methods never use inside a lock. It can cause deadlocks. Okay. So do slim locks. So in these two examples, okay, this is a fat lock, this is a slim lock. Here we are doing the download inside the lock. Here we are doing the download outside the lock. But the map dot put we are doing inside here also. So the heavy operations try to bring outside of the synchronizer block. Okay. So the lock held for nanoseconds. Otherwise, lock may held for milliseconds, right? So that is not recommended. Make it more slim as much as you can. So for fourth fix is use higher level APIs. This is the one nowadays we are following. It's very important. So you don't need to bother about locking, unlocking, and everything. You can make use of the inbuilt APIs, executor service, concurrent hash map, atomic integer, read write lock. So all these are comes with java.util.concurrent package. For concurrency itself, Java is having a package. So make use of it so that no deadlocks will happen. It's very safe and it is optimized because it's a Java inbuilt library. So try to use these libraries. So executor services manages thread pools and task scheduling automatically. That you know, right? Concurrent hash map, thread safe map with fine grained locking bucket level. I have done already a video about concurrent hash map. Atomic integer, lock free thread safe variables using compare and swap. This is also comes in concurrent package. It's also you can use in multi-thread applications. Instead of integer, you can use atomic integer. Read write lock allows multiple readers or one exclusive writer. Okay. So multiple readers are allowed, but at a time. Okay, at a time multiple read can happen, but only one write at a time. Okay, that is read write lock. So this boosts the performance in read heavy applications. Okay. So these all are the very commonly used ways or higher level APIs. This comes along with java.util concurrent so that you can use it to avoid deadlocks. So these all are just comparisons. Two ways your application stops making progress. One is deadlock, one is live lock. Deadlock is frozen state, live lock is busy state. Okay. Deadlock blocked, live lock active running. Deadlock progress none, permanent halt. Live lock progress none, stuck in a loop of state changes. Deadlock 0, CPU usage 0 or low. Threads are not consuming cycles. Okay. But in live lock it is high or maximum CPU usage, wasting resources doing nothing useful. Deadlock it is infinite waiting for a resource held by another. In live lock it is a state churn, constantly changing state to avoid conflict. It's a comparison table. You can have a quick look here. Then deadlock versus starvation, blocked resources versus unfair resource allocation. Okay. Deadlock and starvation is a cause. What causes deadlock is mutual blocking there are many 4 conditions, right? So one is mutual blocking. In starvation, unfair scheduling, low priority or greedy threads. In deadlock, its state is blocked or waiting, thread is blocked waiting forever. But in starvation, it is runnable, ready to run, but never chosen. Deadlock, permanent halt. Starvation, infinite wait, may eventually processed, may eventually proceed. Deadlock, it remove cycle. Okay, how to fix deadlock. Remove the cycle. So already I explained how to remove deadlock and what causes deadlock. Everything I discussed already. In starvation, fair policies, adjust thread priorities and fairness. Okay, this also comparison. You can have a quick check. So common deadlock scenarios: nested synchronization, database deadlocks, cache plus database, distributed cycles. Common root cause is inconsistent global ordering of resources across the system. Okay. Nested synchronization, I already explained. Database deadlocks, two transactions updating multiple rows or tables in inconsistent orders. The DB detects this and kills one. Okay, that is called database deadlocks. Cache plus database, holding a cache lock while waiting for a slow DB connection, blocking other threads needing the cache. That is deadlocks in cache. Distributed cycles, circular dependencies between microservices via synchronous HTTP calls. Service A calls service B and waiting. Service B calls service A and waiting. This is the distributed cycles. Another deadlock scenario. These are the common deadlock scenarios. There may be more scenarios. Okay. So interview questions, you can expect what are the deadlock conditions. It's the Coffman conditions we call: mutual exclusion, hold and wait, no preemption, circular wait. How do you prevent deadlocks? Lock ordering, lock timeout, try lock, reduce scope. Deadlock versus live lock, blocked state, active state, CPU usage, state change. You can explain. How to detect in production. Thread dump, jstack, VisualVM, APM tools. Jstack and VisualVM I already demoed. Thread dump also I showed you. Okay, so these are the questions you can expect. Best practices: avoid nested locks, enforce global lock ordering, prefer concurrent utilities, use timed locks. Okay. So production monitoring, active monitoring metrics. Okay. Thread state is wait time 30 seconds. Alert triggered, possible deadlock detected in module payment service thread 14 waiting for lock. This one. This kind of monitoring we can set up so that it will give you alerts if one thread is waiting for more than a particular time. Okay, so in summary, circular waiting deadlock occurs when threads form a closed dependency loop, each waiting for a resource held by the next. 4 conditions are there for deadlock. Deadlock only happens if mutual exclusion, hold and wait, no preemption, circular wait all exist. Debugging is hard. Apps hang silently with low CPU usage, often non-deterministic and hard to reproduce the local tests. Prevent with design. Use trilog to enforce global lock ordering or use higher level concurrency utilities. So higher level concurrency utilities means concurrent hash map, executor service, atomic integers, or read write lock. So that is the safe and optimized way of using this higher level APIs in the multi-thread applications. So here, thanks for watching. Before you leaving, I will show you how to fix this. Okay, so I am going to my ID once again. So all are whatever I showed here, I have code written. So deadlock fixed ordering. Okay, here I will run and show you how to do this. So you can see thread 1 acquired lock A, thread 1 acquired lock B, thread 2 acquired lock A, thread 2 acquired lock B, both got executed and completed successfully. Okay, here what happened, it's a runnable task. I created a task lock A, lock B. Inside task I have synchronized lock A, synchronized lock B, acquired lock A, acquired lock B, both thread 1, thread 2. So here you can see I am creating new thread and task is this. Okay, new thread, and I am giving thread 1 as name here, thread 2 as name here. I am starting this. So thread 1 starts this, then thread 2 starts this. Both are correctly acquiring lock A and lock B, so that the execution is happening very smoothly. There is no error. You can see is ran successfully, process finished with exist code. Okay, so both acquired the lock very correctly, so no issues. So this is what happened here. The order we corrected, both are getting in the same order only, A, B. Okay, that's why no deadlock is happening here. So deadlock fixing with the try lock. If I am running this, you can see process is completed successfully, both acquired lock A and B correctly. So here I am using this re-enter lock, and here you can see I am checking lock A dot try lock. So time is 1 second. 1 second only it will check. If it is success, it acquire the lock, it will come here and it will print it acquire the lock. Then it will try to acquire the second lock. 1 second is the time. If it can acquire in 1 second, it will again print lock B. So this is the use of try lock in re-enter lock, so that no thread lock will happen. Okay, these are the two examples. So that's all about deadlock. So thanks for watching this. Please like and subscribe if you like this. If you have any questions, please add it in the comment. Thank you so much.